Okay, welcome back. We're going to start a new playground. So you can go up to File, New Playground, and I'll just call this one Types of Variables. Go ahead and save it. Okay, once that's open, go ahead and resize it if you like. I'm going to get rid of this top comment here. We don't need it. And we'll start with the variable str. So that is a string. And a string is declared as something equals, and it's going to be text in these quotation marks. So the variable str is a string. So for example, if we're going to declare a constant, how about date of birth, quotation mark, January 1st, 2017. That's a constant, which is a string. How about variable, favorite food? If we wanted to explicitly declare it, we would do colon, then the word string, and an equal sign, and then whatever we want to declare it as. So this is a implicit declaration, and this is a explicit declaration. Okay, how about numbers? Well, there's actually three main types of numbers in Swift, and they are integer, float, and double. And you're wondering, what are those differences? Here they are. An integer is a whole number with no fractional component, such as 15, negative 24. A float is a number that does have a fractional component, such as 3.14, negative 40.5, and 0.1. And then a double is a number with a larger, more detailed fractional component, such as this thing here, 5.465700917. Actually, with a double, you have 15 decimal places to use. And so you're probably wondering, when should I use the float or the double? Well, that depends, but it is true. Apple recommends that when there's a situation where a float or a double can be used, you definitely want to use a double. And especially if you want more far accurate math, with equations and whatnot, double is much better. So how do we declare these? Let's do a constant called high score. So this will be the implicit declaration of an integer. Let high score equal 1000. So that's the implicit declaration of an integer. And here is let low score colon int equals 0. So that's the explicit declaration of a integer constant. So how about a float? Well, here's the implicit declaration of pi, shall we say, 3.14. Or how about var 2pi, float equals 6.28. Okay, so there's the implicit declaration of pi and the explicit declaration of 2pi. How about a double? Well, let's let precise number equal 567,719,300,201,0578. Notice on the right side, it's representing itself perfectly accurate. As for explicit declaration of a double, let's do another precise number, colon double equals, how about 146.14560.11309972,357. Okay, there we go. That's the explicit declaration of a double. Okay, so that's strings and numbers in Swift. The next major variable type is called a bool, which is short for boolean, pronounced boolean. I once heard a girl in a programming conversation call it a boolean, and she lost all of her credibility because that is very silly. It is called a boolean. And these are logical variables since they can only be true or false. So for example, how about this? Let dogs are mammals equal true. Okay, so that is a implicit declaration that dogs are mammals. How about let soda is healthy equals false. Another implicit declaration, soda is healthy. That is not true. Everyone knows it's not healthy. It is false. How about a variable of var it is snowing? And we'll explicitly define it as a bool. And currently, as I write this, it is snowing. So yes, that is true. So notice here, notice how these variables are declared. Date of birth is a string, fine. High score, low score, these are numbers, that makes sense. And then dogs are mammals. This is something that could only be a true or false statement, right? Soda is healthy. True or false statement. It is snowing, right? This is the type of style that you want a Boolean to be declared as. This is the type of style that you want a number to be declared as, right? You wouldn't, for example, say let about date of wedding equal true, right? Now, while the compiler is going to recognize date of wedding equals true, that it's going to recognize it as a Boolean, as you're reading through your code, it doesn't make much sense, right? Date of wedding, right? That's a date. That should be a string. Why would it be a true or false variable, right? So make sure when you're declaring these things that the names you actually give them represents the type of variable that you want it to be in the first place. Because as you're reading through the code weeks later, it's going to be much easier on you or whoever else is reading. Okay, so those are the main types of variables: strings, numbers, and booleans. Next, I want to talk about operators. Extremely important in coding, and there's a whole bunch of them, so let me just type them out and then I'll paste them in. So hold on. Okay, so here are the basic Swift operators. There's actually many more operators, but these are the main ones that you're going to use. You're going to use these most frequently, and they get most of the stuff done anyway. So operators allow you to manipulate data and information. So this is the math component involved with your Swift coding and your app development. Let's run through them. Some of them are pretty obvious and easy. Plus sign is adding things. A minus sign is subtracting. The asterisk is multiplying. I spelled that wrong, but okay, multiply things. Hash is divide. The percentage sign is to find a remainder. It may sound strange, but we'll use that later. In fact, we'll use most of these, if not all of them, throughout this course. 2 equal signs in a row is to check if something is equal, right? 1 equal sign means one thing, 2 equal signs means another, right? The first equal sign means you're giving a value. 2 equal signs means you're testing whether two values are equal to each other. We'll definitely use that. Exclamation point and an equal sign is testing whether not equal to. Then, of course, you have your greater than, less than, greater than or equal to, less than or equal to. And 2 and signs in a row is a logical and operator, which is used a lot with booleans and other things. And 2 of these straight line items here is the logical or operator. So yes, we're going to use most of these, if not all of them, throughout the course. But let's go through a couple now just to show you. So let's add 2 numbers together. We declared pi as 3.14, and we declared precise number as this long one. So let's add them together. So it would be pi plus precise number. Go ahead and hit return, and look at that, 570.85. Right, that's correct, right? 567 plus the pi, it's correct. Let's do pi times precise number. What do we get there? 1,782 seems correct to me. Now let's try this. Let's try high score plus pi, and watch what happens here. Oh, we get an error. Interesting. Why is that? We'll check the error and see. The plus sign cannot be applied to operands of type int and double. Okay, so that's just telling you that, sorry, high score is an integer, pi is a double, and I don't know how to add those together. Well, go ahead and comment that out for now. Later in the course, we're going to run into this type of thing, and I'll show you how to fix it. But let's not jump ahead too fast here. Let's just keep going. Let's test out some more of these operators. How about 2 pi is greater than 5? Is that true? Is that false? Well, of course, 2 pi is 6.28, and that is greater than 5, so the compiler tells us, yeah, that's right, it's true. How about this? Let's try 2 pi is less than or equal to 6.28. Is that true? Well, it certainly should be, because 2 pi equals 628, and we're testing if it's less than or equal to. It works. Okay, let's try this one now. Let's use this weird one, the modulo operator, as it's called. So how about high score, percentage sign, the modulo operator, and let's say 3. So what this does is it takes high score, divides it by 3, and returns what's left. Okay, and that's true. That's what we'd expect. 1 is the remainder. Because 1,000, if we divide 3 into it evenly, that would be 999, and there's 1 left over. So the remainder there is 1. Next, we can also use these on strings too. It doesn't just have to be numbers. So let's try this. Let's declare some new names. So let name1 equal Bob, and let's let name2 equal Tim. Now, let's test to see if these things are equal to each other. So how about name1 equals 2 equal sign. So here we're checking, is name1, is it the same thing as name2? Do they equal each other? Of course they don't. One is Bob, one is Tim, so we're going to get the false sign. But now let's use the not equal to operator. So let's just say name1 not equal to name2. So this is testing. Is name1 not equal to name2? And that is true. So of course the compiler returns true. Okay, so that is this playground. We have strings, the different types of numbers, booleans, and the various types of operators. And we've tested a few of them out, and we'll get to the other ones throughout the course. In the next section, we're going to go over the types of collections in Swift. So I will see you then.